Hello everyone, this is question 6 on paper 1 from 2022 Edexcel, and we've got a graphs question. So it says figure 1 shows the sketch of a curve C with the equation y equals f of x, where f of x is a cubic expression in x. The curve passes through the origin, it's got a maximum turning point at 2,8, a minimum turning point at 6,0. Write down the set of values of x for which f dashed of x is less than 0. Okay, so in other words, we have what range of values we have a decreasing function. And we can see from the graph that we've got a negative gradient between 2 and 6. So that's the range of values for which f dashed of x is less than 0. So it's going to be x is less than 6 but greater than 2. That's our answer to part A. Now, it says the line with the equation y is equal to k, where k is a constant, intersects C at only one point. Find the set of values of k, giving your answer in set notation. So the idea here is, let me just quickly sketch our graph. So this is just a rough sketch. Okay, the equation y equals k. So if we have, it intersects it only once. So basically here we're intersecting only once, and up here we're intersecting only once. However, at the actual x-axis, we're intersecting twice because we've got the tangent there and we've got that one there. And if there was a line that was going across here like that was just touching that maximum, that would also have two solutions. Okay, so the range of values in which there's going to be more than one solution is everywhere that I've sort of shaded in the middle there. So what we need is, because it wants to be, what does it say? It says only 1 point. So what we need to do is, let's first of all consider this lower one. So this is going to be the line that has equation y is equal to 0. So the range of values that we want is that y would be less than 0. Okay, so we want the y value to be less than 0 so that there is only 1 point of intersection. So because it's y equals k, we're going to say we want k to be a member of the set of elements where k is less than 0. Or, now up here, if k was equal to 8, we would have two solutions. So we need it to be bigger than 8. So we've got k is a member of the set of elements such that k is greater than 8. Now, in this kind of like set notation, whenever you think about the word or, we use the union symbol. Okay, and if you have to describe it like this one up here, if we were trying to write this one in set notation, this one we could use the and symbol. Okay, so you could do it like that with and symbols, yeah. But when you've got an or, you basically have to do it as two separate ones and you use the union symbol. So in set notation, less than 0 but greater than 8 is written in that format that I've just underlined there. Okay, perfect. Right, that's part A and B done. Now, part C, it says, find the equation of C. You may leave your answer in factorised form. Well, let's think about what do we know. We know that the curve goes through the origin. What's the significance of that? The significance of that is that that means there will be an x on its own outside. You can see from the graph that we also have a repeated root at 6, which means we're going to have an x minus 6 squared. So that's going to give us our three roots. We've got 0 and we've got 6 squared. Now, the only thing we need to compensate for is that there might have been some scale factor parallel to the y-axis, okay? Because remember, if you have a stretch parallel to the y-axis, it doesn't affect the points that lie on the x-axis. So it's not going to change our solutions. So we need to write in instead an a in the front there to compensate for the fact that there's been this stretch of scale factor something parallel to the y-axis. Now, because we've got a point on the curve, the point 2,8, we can sub in the point 2,8 into this to work out what a is. So we have the y is 8 when x is 2. Okay, so we put all that in and it turns out that we end up with a is equal to 8 divided by 32, which simplifies into a quarter. So therefore, the full equation of the curve is f of x is equal to 1/4 x times by x minus 6 all squared. But the key idea there was including this term a, which accounts for if there had been a stretch parallel to the y-axis, which they had in this case of scale factor 1/4. Okay, I hope you found that helpful, and I'll see you in the next video.